Welcome to the next lesson where we are continuing our project setup. We have to write a bit more boilerplate code to add support for EF Core and introduce our database. I will be using Postgres throughout this course, which is an amazing SQL database, but if you want to, you can exchange it for another EF Core compatible database, except you will be responsible for managing any differences. As part of this lesson, we will also create our first entity, which is going to be our habit that we will be tracking in the dev habit application. And here's an example of what a habit might look like as a JSON object. Now I'm going to translate this into a C# object when we jump into the code, but I just wanted to give you a visual example of what you should expect when we start creating our first entity. I'm going to explain all of these properties in more detail when we jump into the code, so let's move over into Visual Studio. This is where we left off from the previous lesson, where we scaffolded our initial project. We set up build configuration, central package management, observability using OpenTelemetry, and we also added some external sources where we can export our telemetry data. On top of that, we also containerized our application and we added Docker support orchestration, which is going to make it easier for us to run our database. But before we introduce our database, let's set up what we need inside of the application. And I will begin by installing the required EF Core NuGet packages. So I will click Manage NuGet Packages on the Dev Habit API project, and let's go into Browse, and I will type Entity Framework Core. Because I will be using Postgres, I want to install the respective EF Core provider, which is MPG SQL Entity Framework Core PostgreSQL. So let's go ahead and install the latest version, and I will also install the package manager tools so that I can easily create my migrations from the package manager console. So let's go ahead and install this NuGet package as well. Now I also want to introduce another NuGet package, which is called EF Core Naming Conventions. And this will allow me to configure some naming conventions on my EF Core database models to use the snake case naming convention, which is specific for Postgres. If you are fine with using the default naming convention with EF Core, then you can omit this package. So now I can close this down. And before we create our database context, let me show you what we have inside of our project file. You can see that all we have are project references to the EF Core packages that we just installed. And this is because we are using central package management. If I take a look at the directory packages props, you can see that I now have some additional packages here, which specify the package versions of the EF Core specific NuGet packages that I just installed. So let's close this down and let's start creating our database context. Now I want to create a folder in the Dev Habit API project. So I will add a new folder and let's call it database. Inside of this folder, I will add a new class, and this is going to represent my database context. So I'm going to call it the application DB context. I will make this a sealed type, and I'm going to implement from the base database context class, which is available from EF Core. Now I'm going to create a constructor right away, and I prefer using primary constructors. And inside of it, I'm going to specify the database context options type and specify my specific database context implementation as the generic argument. Let's give this a name of options, and I'm just going to pass this to the base constructor of the database context type. Another personal preference of mine is making all of my types sealed if I don't want them to be inheritable. This is the case for my database context, which is why I'm marking it as sealed. Now let's move into some configuration. I'm going to override the onModelCreating method, and here I want to configure some basic things that I think make sense when setting up EF Core. And one of those things is having a default schema for all of your tables. So let's say I want all of my tables to belong to the Dev Habit schema. I can do that by saying Model Builder has default schema and specify Dev Habit. Now another thing that I recommend that you do, instead of hard coding configuration values like these, is to define them as a set of constants. So what I can do is create a static class, and let's call it schemas. And inside of it, I can create a public constant string value. Let's call this the application schema because it belongs to the application database context, and I'm going to assign it the value of Dev Habit. So now I can say schemas and specify application instead of hard coding the value. This will also help us in the future when we introduce another database context. You will see why we're going to need that one, and adding the schema for the second database context is going to be simpler with the schema's static class. So I'm going to move this into its own file, and now let's go back to our database context. What do I need to do next to set up my database context with dependency injection? I will go into the program file, and for example, let's add this code right above the OpenTelemetry setup. I can say builder services, add database context, and I can specify my application database context. This also accepts a delegate where I can configure some additional settings. For example, I want to say use MPG-SQL to connect this with my Postgres database. Now I will need to pass in a connection string, so I can say builder configuration get connection string, and let's say that my connection string name is database. I also want to do a few more things here. First, remember that we installed the naming conventions NuGet package, so now I can say use snakecase naming convention. But another thing that you can do is also configure the migration history table on your database context, and you can do this from the use MPG-SQL call. So I'm going to pass in another delegate working with the MPG-SQL options builder, and here I want to say migration history table, and this lets me assign a name and a schema for the migration history table. All of this might seem cumbersome right now, but it's going to make a lot of sense when we introduce another database context that we will need for supporting authentication tables using ASP.NET Core Identity, so it's better to do this work right now than run into conflicts later. Now, if you want to pull the default table name for the migration history table, you need to access the history repository, which has a default table name constant. As for the schema, we already defined that, and it's available in the schema's static class, and we have the application schema. So now all of the tables belonging to this database context, as well as the migration history table, are going to live in their own schema. What about the connection string? We don't have it right now, but for example, we could configure it in the application settings development JSON file. I'm going to create a connection strings section at the top of this file, and let's create a database connection string. So now we run into our next problem, and this is which database instance are we going to connect to. So I'm going to set up a database inside of my Docker Compose YAML file, and I'm going to paste in the configuration right below my DevHabit API service. I'm going to call it DevHabit Postgres, and I'm going to specify a specific Postgres version that I want to be running. It's going to be 17.2. For the environment variables, my database name will be DevHabit, and the default username and password will be Postgres and Postgres. I'm also going to set up a volume so that I can persist my application's data between application starts, and I'm also going to expose it locally on the port 5432 so that I can connect to my Postgres instance from some management studio. So now that we have our Postgres service ready, we can define our connection string. So let me add it here. The host is going to be DevHabit Postgres. This is the same value as the name of the service specified in the Docker Compose YAML file. The database name is also what we specified in the environment variable, as well as the username and the password. The next thing I'm going to add is a small helper method that's going to help us apply our database migrations. So back in the DevHabit API project, I will add another folder, and let's call it extensions. And this is where I'm going to define some generic extension methods. Now inside of this folder, I will add another class called database extensions, and this will be a public and static class. Inside of it, I'm going to define an async method, and I'm going to call it apply migrations async. It's going to be an extension method on the web application type, and of course, for it to be an extension method, it must be static. So what am I going to do here? I need to resolve my database context instance from dependency injection, and I can do that by accessing the service provider and creating a service scope. So let's define an iService scope inside of a using statement so that we can dispose of any database context when we are done with applying our migrations. Now I'm going to use this code completion, which suggests using the async disposable, but it won't be wrong if you were just to use a simple using statement. So now that I have my database context, I can go ahead and say await database context, access the database facade, and then invoke the migrate async method. Now I do want to wrap this inside of a try catch statement. let me move the migrate step into the try statement. And for example, after I'm done applying the migration, I can add an information log that the database migrations were applied successfully. In the catch statement, instead of logging to the console, I'm going to add an error log that an error occurred while applying my database migrations. So now I can use this method inside of the program file, and I only want to run this in development. So here I'm going to say await app apply migrations async, and this is going to run my database migrations when I start the application. Now I'm stressing that this is only for development, which in my case is going to be local development, and we are going to use a more production-ready approach when we tackle deploying our database. So now I can finally introduce my first entity, and I'm going to create another folder to host these types, and I will call it entities. Inside of it, I will add a new type called a habit, and this will represent our first domain entity. So let me define a couple of properties that I will need inside of this type. I'm going to use a string for the identifier because I want to be able to construct a string with a prefix. Then I want to assign a name to the habit, and this is going to be a required field. But I also want to have an optional description that you may or may not want to specify when creating the habit. I won't be using any private setters or rich domain models. Everything will just have public getters and setters because I don't want this to be any more complicated than required. Now we will need a couple of additional types. For example, I'm going to need an enum to define my habit type, and I'm going to have a default value of none, which is going to be 0, and then I can have a binary habit type, which is all about completing some specific task or not completing it. And I'm also going to have a measurable habit type where I can actually track some values. So let's specify the habit type here in the type property, and then another type that we will need is a frequency for how often we want to perform this habit. And let's make this its own type. So I'm going to define a frequency, and inside of it I'm going to have a frequency type property, which is going to allow me to count how often we want to perform a specific habit or a given frequency. So I'm going to call this times per period. Let's give it a getter and a setter. And then let's define our frequency type enum. I'm going to support a couple of frequency types. We won't have a default value. And then we're going to start from daily, weekly, and monthly in terms of the frequencies that we want to track inside of our habits. So now that I have this, I can go ahead and define the frequency property inside of my habit entity. The next thing I'll need is a way for me to track if I have achieved a specific target for a given frequency. And for this, I'm going to introduce another type. It's also going to be a simple value object, and I will call it target, and it's going to have an integer value, and another property is going to be a string representing the unit of the specific value. We could constrain this more with some proper value objects, but we're going to manage this through some validation that we will implement and also through the user interface. Then I want to be able to track the status of my habit, so I'm going to create a habit status property. This is going to be another enum, so let's define it right below the habit type. And the default status is going to be none. And then we're going to have some specific values, an ongoing status for any habit that we haven't completed yet, and then a completed status